how do you determine what IMFs are present? Ask yourself, what is interacting? That's what IMFs are. They are these attractive forces that hold particles together. So the stronger the IMF, the greater the force it takes to overcome that. Now remember what IMFs are. They're not the chemical bonds, but they're these attractive forces, and it has to do often with slightly positive and slightly negative charges. Now remember, Coulombs Law still applies here. Remember, Coulombs Law related charge and then the distance between those charged particles. So force depends on charge and distance. Now, generally, I'm going to give you the lineup. What's stronger? Okay, generally, here we go. Strongest to weakest. Network covalent is something like a diamond. Okay, we'll get there later. Ionic compounds next, ionic forces. Then covalent bonds. Okay, so we've just dealt with chemical bonds. Now we are down to IMFs. So the strongest IMF is generally hydrogen bonding, then dipole-dipole, and then London dispersion forces. I say generally, not always. Sometimes they can mingle. Okay. Now, other attractive forces that we need to be considering is ion to dipole, right? Because we have a positive or negative and a slightly positive, slightly negative, and then ion-ion forces. So let's talk about what are we looking for. First of all, how do you determine what IMFs are present? Ask yourself, what is interacting? Is it a molecule? Is it ions? Do we have both present? Then look for polar molecules, because polar molecules can lead you to our dipoles. And then also look for hydrogen bonding. So that hydrogen, remember, has to be bonded to an F, O, or N in order to have hydrogen bonding. So let me give you one other little point about dispersion versus dipole-dipole. Generally, dipole-dipole forces are stronger than dispersion forces. But at what point do dispersion forces become very significant? And they can. And that is when one molecule is much larger. So if we have one really large molecule, it has a bunch of electrons, the dispersion forces can overtake the dipole-dipole forces of something else. And so this is just one little thing. You might want to make a note of that. And that can influence physical properties. Now, let's talk about physical properties and how this relates. Okay, think about magnets. The stronger the force attracting magnets. One time I had a student bring in some neodymium magnets that were so strong, I couldn't physically pull them apart. It was crazy. So think about it. The stronger the magnetic force, the greater the force it takes to overcome that force. Well, that's what IMFs are. They are these attractive forces that hold particles together. So the stronger the IMF, the greater the force it takes to overcome that force. So let's just look at one. I want to talk about, well, there's several properties here that you need to think through based on IMFs, but let's just talk about boiling point. So let me give you an example here. If we were to compare two substances, the boiling point, we're going to compare the polarity of the molecule. Let's say I had one molecule that was more polar. Let's say it was HCl versus HPr. Okay, this one is more polar, right? And so what does that mean? That those particles are attracting each other, they have stronger attractions. So we would need more energy to pull them apart. Therefore, you would expect HCl to have a higher boiling point. Okay, so we are going to use these intermolecular forces to predict or explain some of the physical properties. Viscosity is resistance to flow. So think about it. If molecules were more attracted to each other, then that liquid would have a higher viscosity because they are attracting each other, and that would resist the flow. Surface tension, adhesion, cohesion, capillary action, those all have to do with intermolecular forces. So this takes a little practice to first identify the intermolecular force and then use that to predict the difference in physical properties. Also, you may be given physical properties and have to predict the IMFs based on those.